Hello and welcome to the course on Python for data science. In this lesson, we will go through some Python basics like functions, iteration, and recursion. We also cover basic processing of strings and lists. Our recommended textbook for the course is Python for Data Analysis by Wes McKinney. For basic Python, we recommend Think Python, How to Think Like a Computer Scientist by Alan B. Down. First, let us look at functions in Python. Functions may be built-in or user-defined. Built-in functions examples are print, type, input, max, min, etc. User-defined functions help in code reuse and in organizing and simplifying code. Here we illustrate the built-in function max. With numeric arguments, it returns the numeric maximum. With a single string argument, it returns the character with the highest ASCII code. With multiple string arguments, it returns the lexicographically largest string. A function is defined in Python using the def keyword. It is invoked or called by using the function name or identifier along with the arguments. This example shows a function with multiple arguments. A function may also return multiple values. A void function returns no values. Functions which return values are called fruitful. The scope of a variable defines the part of the program where the variable can be assigned or referenced. The scope rules of a language determine how a particular reference to a variable is associated with a declaration. Scoping rules in Python are based on functions. In Python, the scope of a local variable within a function starts from the point of creation and ends with the last statement of the function. In the example shown, the scope of b and x is within the function +4. Recursion is a mechanism in which functions invoke themselves. Some problems can be modeled recursively in a natural way. This often leads to elegant solutions. Recursive functions have a base case which enables us to terminate it. In the example shown, we are computing Fibonacci numbers using the recursive definition which defines a Fibonacci number as the sum of the last two Fibonacci numbers. Here n equals 0 and n equals 1 are the base cases. Iterations in programming languages refer to the repetitive execution of a block of code until a specified condition is met. This fundamental concept allows developers to automate repetitive tasks, making programs more efficient and easier to manage. Iterations can be implemented using various constructs such as loops, including for, while, etc. Each type of loop serves different purposes. For loops are counter-controlled and are typically used when the number of iterations is known beforehand. While loops are logically controlled and are used when the condition is evaluated before the execution of the loop body. The example shows a while loop. This prints numbers from 13 to 20. Once n is 21, control exits the while loop. In this example, we count downwards. The loop control variable is gradually reduced. Here the while loop runs forever. Python provides a loop control mechanism break, which allows control to shift out of the loop. This example illustrates the usage of the break statement. Continue is another loop control mechanism, which allows us to shift the control to the beginning of the loop. The for loop uses a counter to control the loop. In Python, the for loop is controlled by looping through any objects, which are iterable like lists, tuples, strings, and dictionaries. Here we show examples wherein the for loop enables us to iterate through a list, a tuple, and a string. Next, we will look at strings in Python. Strings are made up of smaller units, characters which can be deemed to be strings of size 1. Both single and double quotes can be used to denote strings in Python as shown in the example. We may access the whole or part of a string. Here we show the usage of the built-in len function to find the length of a string in Python. Slices of a string may be extracted, similar to the way we extract slices of a Python list. Strings may be compared lexicographically using various comparison operators. Strings in Python are immutable. meaning that once a string is created, it cannot be changed. To change a string, we have to essentially create a new one. In the example shown here, to change the word mango to tango, we simply cannot replace the M with a T. A useful string method is the find, which returns the starting location of a pattern substring within the string, or returns a -1 on failure. Here find locates the substring do in the string avocado. Next, we look at Python lists. Lists are one of the sequence data types in Python. A list in Python is an ordered collection of items, which can be of any data type, including integers, floats, strings, and even other lists. Lists are defined by enclosing elements in square brackets, separated by commas. One of the key features of Python lists is their ability to hold heterogeneous elements of different data types within the same list. Here, we construct a list from a range. An element in a Python list may be accessed using the square bracket notation. If there are n elements in list B, we can access the elements as B0 through Bn-1. B-I is an alternative way to reference Bn-I. In this example, we apply various operations on a list of integers. Membership queries on a Python list can be asked using the in and not in operators. The plus operation concatenates two lists. Repetition can be implemented using the asterisk operation. Examples of slicing operation O lists are shown here. Some more examples of slicing operation on lists are shown here. Unlike strings and tuples, lists are mutable in Python, which means a list can be modified. In the example, the element at location 0 is updated from 3 to 13. This example shows an instance of multiple assignment on list elements. This example shows an instance of multiple assignment on list elements. Examples of insert and delete operations on a Python list are shown here. The assignment operation list1 equals list2 merely creates list1 as an alias of list2. Any changes on either of the two lists is reflected on the other. This is known as list copying. Unlike simple list copying, cloning creates a new copy of a list. Passing a list as a parameter to a function actually passes a reference, not a copy. In the example shown, the first element of the original list, which is passed as a parameter, is deleted. Python supports nested lists. Elements inside such nested lists may be referenced using multiple square brackets, which are evaluated by the Python interpreter in a left-to-right order. Thank you. This course is brought to you by Elahay Technologies.